Hey there, welcome to Kung Fu Physics. I got a really easy mechanics problem for you right now. We are going to do number 40 off of the 1992 exam. So it's number 40, 1992. Pull it up if you've got a copy of these. Now I am getting more organized the further along I get with these problems, and I actually made some new print-offs of them. I like to cut the problems up so that I can shuffle them around and group them together as far as what type of problem they are, so I can see the similarities between the exams, see the common things between the different practice exams, things like that. So I've got them printed out on different colors, and hopefully I'll be able to remember which exam is which. So different exams are different colors, right? So what I have for you today is the first of maybe many of these combinations that when you see me holding up something like this, I've got three problems that are using a very similar set of tools to solve them correctly and quickly. And so when you see three colors like that, you know it's a pretty common problem that tends to get thrown around on the physics GRE, and there will probably be some incarnation of something like it. So anyways, that is the case for the problem today. In all honesty, the problem today is probably even easier than the other two that I've already done. And so I'll cross-link these for you. I'll read off what they are as well, and so you can go back and look at those if you want to. But without further ado, let's go into problem number 40 off of the 92 exam. So a quick glance at the answers doesn't help me much. I'm going to be choosing from some type of direction or no direction apparently, but I got to move fast through those answers. So on to the problem. Number 40, a rigid cylinder rolls at constant speed without slipping on top of a horizontal plane surface. The acceleration of a point on the circumference of that cylinder at the moment when the point touches the plane is. So this is a highly conceptual problem, and you don't need much to solve it other than, you know, clear thinking and an understanding of what's actually going on here. So maybe a quickie little diagram. You might want to draw this for yourself, or you might just want to think this in your head if you're actually doing the physics GRE. But I thought something like that would be helpful to draw for the purposes of this video. There are two types of motion that every point on this cylinder is exhibiting. One is the rotational motion, and every point is moving around in a circle, and as the problem has told us, it's moving around at a constant velocity. In other words, the thing is spinning at some angular frequency, let's say omega, and it's not increasing or decreasing. So it's a constant angular speed. It is having a transverse velocity as well. Its velocity is going that way, as well as the particles inside the cylinder. So their combined motion is going to be a combination of those two velocities, the rotational velocities and their translational velocities. And that's velocities. Now the problem, of course, asks for an acceleration. Now it's important to note that this thing is not accelerating in the transverse velocity at all. It's said that that's constant, so there's no acceleration that way. There's no acceleration up or down. In other words, the normal force at this point is balancing with the mass of the cylinder, so we don't have any acceleration up or down. So is the points, let me rephrase that, are the points anywhere on this thing accelerating? If you don't know, think about any other situation where you've had this happening, where you've had a car going around a track at a constant velocity or something like that. Is the car accelerating as it keeps a constant velocity but is turning its wheel to maintain its velocity in a circular path? Yes. Yes, a physicist knows that when something is changing its direction, it is accelerating. And in the case of anything that's going around in a circle and maintaining a constant velocity, it's what we call a centripetal acceleration, a center-seeking acceleration. And so every point on this cylinder is in fact accelerating towards the center. Its acceleration could be calculated. The acceleration equals v squared over r, not to be confused with this v, the translational v. I would want to use different v's to represent those. It would be the instantaneous speed, the v, tangent velocity, the velocity to the tangent, the instantaneous tangent velocity. Anyways, it has a center-seeking acceleration. And so for me, this problem just seems really easy. I mean, I know if the point is here, I do have to be careful reading the problem carefully that the acceleration is here. And so I would say, without thinking about it too much, that the acceleration is going up. And check my answers. Of course, that is one of my answers. It's answer C. The acceleration being directed up. So answer C on problem 4092 exam. And if things were going good, I would like to think that if I was actually taking the physics GRE, I could scan that problem and answer that in like 30 seconds or less and give me a little bit more time for some of the harder problems. If things were going good and I had a clear picture conceptually, I would make the answer, maybe double check it once, but try and get a problem like that really fast, because I would put this in the category of a very easy problem. Conceptual mechanics, very easy problem. Now, as I promised, I will cross-reference this a little bit. If you still have issues with acceleration and velocity vectors, look at some of the other problems that I've already posted here. Number 5 off of the 96 exam is a good one to look at, and number 23 off of the 2001 is a good one to look at. And yeah, that would be my advice. So that's all for now. That's the solution to number 40 off of the 92 exam. As always, thanks for watching. See you next time.